Intelligent devices like programmable logic controllers and remote terminal units and loop controllers, and many more in fact, all have memory. And the memory in these devices are used to store programs, data, backups, and many other things. Now, if a device is Modbus compliant, it must have a portion of its memory dedicated to Modbus. This area is called the Modbus memory area. So that is what we are going to look at in this lecture. Now let's say I represent the entire Modbus memory area in a particular device by this rectangle. One of the key things to remember is that the Modbus memory area in most devices that are Modbus compliant are divided into 4 separate areas or sub-areas. These memory areas have some kind of strange names, but let's look at them now. First off, we have coils, then inputs, then input registers, then holding registers. Told you the names were strange. Now all of these areas, as with all memory, consist of memory blocks. The coils and inputs, their areas consist of 1-bit memory blocks only. The input registers and holding registers, their areas consist of 16-bit memory blocks only. Let's look at the memory addresses of these blocks. The memory addresses in the coils area run from 1 to 10,000. Hence the coils area has 10,000 1-bit memory blocks. The memory addresses in the inputs area run from 10,001 to 20,000. Hence this area also has 10,000 1-bit memory blocks. The memory addresses in the input registers area run from 30,001 to 40,000. Hence the input registers area has 10,000 16-bit memory blocks. The memory addresses in the holding registers area run from 40,001 to 50,000. Hence this area also has 10,000 16-bit memory blocks. This particular concept, this set of information is extremely important for you to remember, because this is the typical arrangement of memory or Modbus memory in a device that is Modbus compliant. So now you know what the Modbus memory area typically looks like in a Modbus compliant device. This is it. But why does it look like this? Why 4 areas? Well, as I had said in an earlier lecture, the Modbus protocol was originally developed for PLCs to communicate with one another. PLCs at that time typically had only 4 types of connections on them for sensors and actuators. They were discrete inputs, discrete outputs, analog inputs, and analog outputs. Now let's just take a quick look at them. Discrete inputs, you would connect to discrete inputs, you would connect sensors like switches, for instance, that would have only an on and an off. Discrete outputs, that's where you want to connect actuators, for instance, to open and close a valve per se. Analog inputs, things like pressures or temperatures or flows, and you wanted to connect sensors, pressure sensors and temperature sensors back to the PLC to get those readings, like say from a pipeline or something. You connect the analog inputs. Analog outputs is where you want the PLC to control a device. Let's say a variable frequency drive. It controls the speed of it. So these were the 4 types of connections. PLCs needed to store data in memory that had to do with these connections. Hence, that is why there are 4 areas to store these 4 separate types of data. So let's go through them. The coils area was used to store data on discrete outputs. The inputs area for discrete inputs. The input registers area for analog inputs. The holding registers area for analog outputs. So that's the reason actually that we have those 4 areas, because the PLCs back then had these 4 types of connections. So now this has been a very, very important lecture. Knowing the typical memory map of the Modbus area in a device is essential to creating a proper Modbus RS-485 network.